This is the notes for Unit 8, Lesson 12, Quadratic Word Problems. Now that we know multiple methods of solving quadratic equations, which are factoring and completing the square, we can now use them for word problems. All right, so which method you use is up to you, but I would suggest using factoring. It's easier. All right, let's look at exercise 1. Consider a rectangle whose area is 72 square feet. We know that the length is 10 feet more than twice its width, and we want to find the dimensions of the rectangle. So if I draw a rectangle, here's my rectangle, and it says to represent the width using W. So here's my W, and then write an expression for the length using W. It says the length is 10 feet more than twice the width. So that would be twice the width and 10 feet more, which is 2W plus 10. Okay, so now set up an equation that could be used to solve for the width W based on the area. Well, how do you find the area? Area is equal to the length times the width. So that means if I take these two values, W times 2W plus 10, that will give me the area, which is 72. Length times width equals area. Okay, so now let's solve this equation. Well, I have W times 2W plus 10 is equal to 72. So I need to distribute 2W squared plus 10W equals 72. And since this is quadratic equation, we want it equal to 0. So we subtract the 72. And that gets it equal to 0. All right, now notice something about these numbers, 2, 10, and 72. They all divide by 2. So let's do that. We're going to divide everything by 2. Make sure you divide the 0 as well. So that gives you W squared plus 5W minus 36 is equal to 0. Okay, so now it's a quadratic equation. It's equal to 0. I'm going to do this by factoring. All right, so I'm going to make my two sets of parentheses. You can make your box off to the side if you want to. We know this is going to be W times W, and we need the factors of negative 36 to add up to be 5. You can use the calculator trick if you need to, but 9 times 4 is 36. And to get it to be 5, it would have to be positive 9 and negative 4 equal to 0. All right, we're going to set these equal to 0. W plus 9 equals 0. W minus 4 is equal to 0. Solve this for W. We get W equals negative 9. And we get W is equal to 4. All right, now, why is one of the solutions for W not viable? We can't use. All right, viable means we can't use it. Well, can we have a negative length? No, we can't. So W equals negative 9 we can't use. You can't have a negative length. So that means the width would have to be 4. So if our width is 4, that means our length is going to be 2 times 4 plus 10, which is the length, which would be 18. So if the width is 4 and the length is 18, 18 times 4 is 72, and that is the area of the rectangle. All right, let's try one that uses systems. A rectangle has a perimeter of 48 feet and an area of 135 square feet. We're going to use L and W for length and width. We're going to use appropriate variables. We're going to use L for length. Remember, there's 2 lengths and there's 2 widths on a rectangle. So if I write a system of equations based on this, we have to use L and W to find the perimeter. How do you find perimeter? Well, perimeter means to add up all the sides, so that means 2 lengths plus 2 widths will equal 48. All right, the other piece of information that I have is the area is 135. Well, we decided the area is the length times the width, so that's going to be L times W will equal 135. All right, now it says using substitution, solve the linear quadratic system to determine the dimensions of the rectangle. So that means we need to solve one of these equations for either L or W. I'm going to solve the first one for L. It's going to be a little bit easier than the second one. All right, so to solve this for L, I'm going to subtract the 2W. And I get 2L is equal to 48 minus 2W. And then I want to divide by 2. So L is equal to 24 minus W. So if I'm using substitution, I'm going to take this L equals, and I'm going to plug it in right there. in the second equation. So it's 24 minus w is the length times the width is equal to 135. All right, I'm going to distribute. 24w minus w squared is equal to 135. All right, so this is a quadratic equation. We want to equal to 0, but we also want a positive w squared. So I'm going to move this stuff over to the other side so that I have a positive w squared. Makes your life much easier. And I'll put it in standard form once I get it written over here. So in standard form, this would be w squared minus 24w plus 135 is equal to 0. Okay, so now I can factor this. I'm going to use my calculator trick for this one. All right, I know this has got to be w and w. All right, now I need the factors of 135. Well, I don't know those off the top of my head. So if I put it in my calculator, it's 135 divided by x, and then 135 divided by x plus x. And I want to go to my table, second graph, and I want to find the factors that add up to be negative 24 in the middle. So we're going to look in the red column for negative 24. Oh, there's negative 24 right there, negative 15 and negative 9. So those are my two factors, w minus 15 and w minus 9. They add up to negative 24, they multiply to be 135. Set them equal to 0. All right, and then solve for w. This one's going to be 15, and this one's going to be 9. Now, can we use both of these answers? Yes, we can, because the width could be 15, or the width could be 9. Well, if the width is 15, what's the length going to be? Well, the length will be 24 minus 15, which is equal to 9. So the width could be 15 and the length could be 9. But what if the width is 9? Then the length would be 24 minus 9, which is equal to 15. So we could actually find one is 15 and the other is 9 for both of them. Well, quadratics can be used for other things besides just geometry problems. There are two integers that have the following property. When the product of one more than 3 times the number with 2 less than the number is found, it is equal to 43 more than the number. So let's find the two integers that fit this description. So my number in this case is going to be x. All right, we're looking at a product, so we're going to multiply something. We're going to multiply 1 more than 3 times the number. Well, if the number is x, 1 more than 3 times that would be 3x plus 1. We're going to multiply it by, because it says product, 2 less than the number. It would be x minus 2. Watch your order on that. It is equal to 43 more than the number, which would be x plus 43. Okay, so now we want to multiply this out to get our quadratic equation. I'm going to make my little box over here off to the side to make it a fast multiplication. All right, here's my box. We have 3x plus 1. We have x minus 2, which gives me 3x squared minus 6x plus x, and then minus 2. So when I combine my terms, 3x squared minus 5x minus 2 is equal to x plus 43. All right, so now this is the quadratic equation. We want to get it equal to 0. We minus the x and we minus the 43. Put them under the respective columns. 3x squared minus 6x minus 45 is equal to 0. What do we notice about all these numbers? They all divide by 3. So we're going to do that. And we get x squared minus 2x minus 15 is equal to 0. Okay, now we want to factor this. Here's my two sets of factors. We have x and x. How do we get negative 15? Well, it'd be 5 and 3. What kind of signs are we going to need? It depends on if we want positive 2 or negative 2. We want negative 2, so it'd have to be negative 5 and positive 3. You can use the calculator if you're not sure, do the box. All right, x minus 5 is equal to 0. X plus 3 is equal to 0. Solve for x. X is equal to 5. And x is equal to negative 3. Okay, now it said to find the two integers. There's the two integers. It works for both of them. So we don't need to eliminate any of them. Okay, so let's do a consecutive integer problem. We haven't done one of those in a while. Find all sets of 2 consecutive integers such that their product is 8 less than 10 times the smaller integer. All right, so I have the first integer is always going to be x. If they are just consecutive, how much are they going to increase by? they're going to increase by 1. So if the first one is x, the second one will automatically be x plus 1. Okay, it says their product, which means we're going to do what with them? We're going to multiply them. X times x plus 1 means equals 8 less than 10 times the smaller. Well, the smaller is x, so it would be 10 times the smaller and 8 less than that. There's my equation, so I have to multiply x squared plus x is equal to 10x minus 8. We want to get it equal to 0, so we're minus the 10x and add the 8. So that gives me x squared minus 9x plus 8 is equal to 0. All right, what are my factors of 8? Well, they're going to be 8 and 1, but if I want this to be negative 9, what kind of signs are we going to need? We're going to need negative signs. So x minus 8, x minus 1, set them equal to 0, and we get x is equal to, add the 8, we get x is equal to 8, and we get x is equal to 1. All right, now we can use both of these integers. All right, now this would be the first integer. If x is equal to 8, then x plus 1 would have to be 9. So one integer could be 8, while the other one is going to be 9. So that's one set. But we actually have two sets. If x is equal to 1, then x plus 1 could also equal 2. So it could also be 1 and 2. So there's two sets of answers for this, depending on what your consecutive integers are. Okay, last one. Brendan claims that the number 5 has the property that the product of 3 less than it with 1 more than it is the same as 3 times the 1 less than it. Show that Brendan's claim is true and algebraically find the other number for which this is true. All right, so what we're going to do is we are going to solve this and show that 5 is one of the answers, and we're going to find the same answer as well. All right, so for my number, I'm going to use x. Okay, and it says 3 less than the number. Well, if 3 less than number, if we have x, 3 less than that would be x minus 3. And then we also would need to know the product of 3 less than it with 1 more than it. If x is the number, 1 more than the number would be x plus 1. It is the same as 3 times 1 less than it. Okay, and we also need to know 1 less would be x minus 1. So we've got 3 less, 1 more, and 1 less. That's what we need to do. All right, so now let's solve the equation. All right, the product means we're going to multiply 3 less than the number. That would be x minus 3. With 1 more than the number, which would be x plus 1. It is the same as, which means equals 3 times 1 less than the number. 1 less than the number is x minus 1. So we need parentheses because we're going to multiply that by 3. All right, so now we need to multiply all this out. We're going to use I'm going to use a quick little box down here to multiply x minus 3 times x plus 1. That gives me x squared plus x minus 3x minus 3. So when I add my terms, I get x squared minus 2x minus 3. And then I'm going to distribute 3x minus 3. Okay, so now this is a quadratic equation. It's got to be equal to 0. I minus the 3x and add the 3. And I get x squared minus 5x. This cancels out, equals 0. Okay, so this is not the box, and it's not difference of squares, so what does that leave? It leaves GCF. So I'm going to GCF out my x, and I'm left with x times x minus 5 is equal to 0. All right, so I actually have two answers here. I have x times x minus 5 means I have to take x and set it equal to 0, and I also take x minus 5 and set it equal to 0. So that means one of my answers is going to be x equals 0. And my other answer is going to be x equals 5. All right, so that is quadratic functions, word problems. So a word problem is a word problem. You solve it just like you normally would, except you're going to be using quadratic equations. Okay, you can go ahead and start your homework.